Hey, thank you, Brandon, and good morning, everyone, to all who are watching. Thanks again for joining this stream to learn more about VSP. It's always nice to run into people whenever I can, even if it is just virtually this time. All right, so if anyone had attended last year's 2024 workshop, I gave a preliminary presentation on this work in progress concept called attributes. And this is a continuation of it as it has now entered OpenVSP's official releases. So we should probably have a little bit more attention to that just to explain the changes that have developed over time with it, as well as just the general concept of it, since this one is an online presentation and presumably many more people have access to watch this one. Right, so let's go on in for a bit. We're going to cover the attributes as a concept, the user interface that has been developed to support it, a few brief examples, and a demo of it. So, beginning with the concept, I'm sure people who have designed airplanes have come up with drawings such as this, where you just start jotting down your notes. You try to associate information with geometry or meta concepts, like what is the materials database we're using for this thing? What's the minimum gauge we'll be allowing for this fuselage, or how many ribs per wing? Or even like we have a section of this wing that has a special attention requirement in CFD because it has like a rubber boot for your de-icing. Or even just this airplane is not classified, things of that nature. Well, you might want to put this in OpenVSP now. So we make our airplane. And then we now represent that same information as attributes. This is the PowerPoint presentation text box, mind you, but same idea works. So we can make this information into notes of varying data types that's associated with various OpenVSP objects. And these notes are both readable by people and by API. So you can store it as notes for yourself or as information for other programs to read and interpret. So attributes really kind of a grease pencil of non-OpenVSP metadata. There are a wide array of attributable objects you can attach attributes to in OpenVSP, not just geoms, but any parm container, any parm. Well, yeah. And most of everything in OpenVSP is a parm or a parm container at its core. In addition, things like measures or sets or modes or even advanced links can all have attributes on them, as well as the vehicle itself at the highest level of abstraction. These are enabled with API and GUI for ease of use and to enable powerful integration with your analysis tools and design suites. And the initial release for this happened in OpenVSP 3.42.0 per a Phase 2 Navy-funded SBIR with M4 Engineering. Again, thank you, Navy, for the funding. It's been very nice to work on this, and we hope you're very happy with it. So we're going to continue into a little more detail here. So an attribute is, if you're used to, say, Python as a programming language, an attribute is similar to a dictionary entry. You have a name and you have a value. Except the type of value here can vary through a number of data types: strings, integers, doubles, booleans, matrices of doubles. You can even have groups of attributes. You can have links to parms as a sort of abstraction for accessing them, just in a similar way if you're getting a lot of information from attributes. But really, it's just, again, it's a name and it's a value. So you say, all right, I'm going to have an integer type attribute. I'm going to call it integer attribute example, and its data will be 55, an integer. And that's really the long and short of an attribute. It's quite a simple concept at its core. The integration, however, has a lot of implications, and you can do a lot of really powerful things with this when fully integrated. I think later today, Maxwell from M4 will be demonstrating some use of attributes in his example work. So stay tuned for that, of course. Moving on. So I'm going to have to trudge through some back end here. The attributes themselves live on what's called the heap, which is just a pile of computer memory that is static, known as non-volatile memory. So no matter what we do with the attributes, they're going to be safe. Meanwhile, the attribute collections may exist on objects that move around, or they might have vectors thereof. And essentially, we had to do a lot of overhaul of how some objects were stored in OpenVSP to make this safer to use. And the safety in using pointers means we have very lightweight objects that aren't nearly as clunky as they could have been, as well as managing a lot of abstract access to them. So attributes live on the heap. Attribute collections store pointers to the pointers, which are the memory addresses of these attributes. And attribute collections then live in OpenVSP objects. And an OpenVSP object could be a geom, it could be a measure, it could be the vehicle itself, it could be a parm, it could be a subsurface. And then lastly, we have the attribute manager, which manages all the pointers locations, as well as pointers to the collections, and centralizes all of the commands that involve attributes. So there's a lot of shuffling going on behind the scenes here, but we developed something that we think is fairly robust and effective. So let's look at some of the ways you might handle the GUI for attributes, because there's been a lot of new GUI features that I think anyone who's used OpenVSP has probably seen by now. So let's bring some light to that. So the main overview here is we essentially have two new big GUI features here. The first one you'll see is the Attribute Explorer, which you can open under the model drop-down menu in the top bar of the OpenVSP. Or if you double-click on any of the attribute items in that Attribute Inline Explorer or Attribute Inline Editor, that will also open the Attribute Explorer to that attribute. So the Explorer is a vehicle-level tree, so you can just navigate the entire vehicle's set of attributes and attribute collections and quickly find which geometries, which objects have attributes and where and what they are. So they'll show the attribute name, its location in the vehicle, its value, and the data type all in the tree. And then on the right-hand side, we have the actual detailed data in case it runs over the short tab delineated version of the tree. We're going to look a little more closely at the tree in a minute. First, let's look at the attribute inline GUI. So this is attached to the bottom of supported objects GUI windows. So say the wing geometry or pod geometry. At the bottom of the Gen tab, you have the attributes for the whole geometry. And then in subsections like the subsurface, you may have subsurfaces in a geometry, and then if those are selected, you will see the attributes associated with that subsurface. So you notice in the right-hand side for the wing geom, we have a wing leading edge patch, and the attributes hierarchy here goes from the subsurfaces to the wing leading edge patch to the attributes collection of the wing's leading edge patch to the arrow mesh size double matrix attribute. Meanwhile, the pod geometry on the left simply just has the pod geom, and then the attribute collection for that pod geom, and then a double precision float attribute for the baggage volume, and then an integer attribute for the minimum skin gauge number of plies. So it's a quick way to preview the data inside of a single object. And again, double-clicking on any of those items in there will open the Attribute Explorer fully with the context of that item you clicked on. Meanwhile, the Global Attribute Explorer provides a top-down view of all the attributes in the model. There are nodes you can open and close in the GUI to make things a little easier to look around at, and it will only display the attribute collections that have attributes in them already, because every parm now has an attribute collection. And if we showed every parm, at surface level, it would drive us to insanity. So there is one exception to that rule, in which if you have a GUI window open of any object, that object's attribute collection will show up in the Attribute Explorer, even if it is not populated. So you can use that to initialize and add attributes to empty collections. It makes more sense when you're using it. We can show that off in the demo a little bit. Further, we have cut, copy, paste, and delete controls in the bottom left. These can work for multiple selections, whether you're copying, cutting, pasting, or deleting. So you could cut multiple attributes, and then you could paste from that clipboard to multiple attribute collections. And this works both for attributes and groups of attributes, which we'll get into later. Sorry, the second thing to point out, of course, is the right-hand side. We have the detailed data screen for the attribute itself. This is a string data, and the strings support entire novels if you wish. You can put any data you want in there, although preferably something a human would read is probably the smartest thing to do for string data, but I'm not going to stop you if you want to do something really weird with it. Above the data screen, we have the add screen. You can select the attribute type and add an attribute, or you can add a group type attribute in case you want to create more hierarchical organization. And lastly, at the top left, we actually have a search bar. So if you're trying to find an attribute of a certain name, you can search by string. You can make that search case sensitive. You can search through any type of attribute, or you can search through any attributable object type as well if you want to down select further. So again, all of this is designed to empower you to figure out what the heck is going on in your model when you open it, because not everyone is the author of the model they're looking at, and frequently you might find something your coworkers made, or even something developed procedurally from a program. Okay, moving on to the second page for the Attribute Explorer. Here's an example of opening an empty attribute collection. So we have on the right a geometry I titled Some New Geometry, and that's being shown in the Attribute Explorer. On the left, it is a blank geom, and we have clicked on it in the geom browser. So its geom screen is open, and that triggers the GUI in the Attribute Explorer to then show Some New Geometry's attribute collection, even though it's empty. And this will work for multiple geometry selections as well. Okay, moving on. All right, I'm going to speed up a little bit here. Attributes support a variety of data types: booleans, ints, doubles, strings, matrices of ints and doubles, vector 3Ds, vectors of vector 3Ds, attribute groups, and parm references. Most of the GUI, the GUI is context sensitive. The Boolean has a simple push button you can click to turn true, false. The attributes for double matrices or int matrices actually have an Excel style spreadsheet widget that Rob built. And for the parm reference, that we actually get the same kind of parm picker we will see as from sets, modes, links, advanced links. And it even includes the slider, so you can drive the parm from this reference to a parm. Attribute groups are very powerful and important because it helps disambiguate similarly named attributes. So you might have multiple materials in your vehicle, and you're going to want to say Young's modulus or E every single time. So you could create an attribute group that says this is your aluminum material properties. Then you could put your E, your Poisson's ratio, your density, and any other string notes in there. Note that material or that attribute groups are actually shown in a magenta colored text, and any OpenVSP object that has a attribute in it is also highlighted in magenta and made bold. So when you're looking through at your parms, you'll see that. So we can see here, take a look at this pod geoms xform screen. We have 3 parms, xloc, yloc, and zloc. All 3 of these have an example attribute in them, and you can see that they are bold and purple. Meanwhile, the geometries, the pod geom and wing geom, have attributes, but the some new geometry does not yet have an attribute. And again, if you're looking, you can use the search bar. let's look at a few quick examples on how you might want to use an attribute. It's not going to be exhaustive because I want to save room for the demo. So we're going to look at vehicle level attributes. There are a few different interesting things specific to the vehicle. First, you can use it as normal. You can put any kind of attribute you want in there, but the vehicle itself in particular has default attributes that are built into the OpenVSP source code that are referenced in specific ways. And these two are watermark data and vehicle notes. And the vehicle notes gets an additional dedicated GUI window. The idea behind that is you could put a little blurb on the context for this model, and you can make that blurb open on vehicle open. So if you have that bool parm set to true, you open up this vehicle, the vehicle notes window opens with it immediately. So anyone opening it can see what you have for them to read. Then watermark data interacts with the render window to create a watermark. You can set the color alpha of the edge, the fill, and the text, as well as scaling the whole thing and setting whether you want it to be visible or not. This could be used for classification status, or even a hello world if you wanted to use it for other things. Moving on, a geom such as a wing, you might want to put the rib quantity in the wing as an integer. You might want to put the spar locations as a double matrix, or control surface deflections as a double attribute, or even minimum gauge layup information as a string. You might have a subsurf on a geom, and this subsurf might contain things like an arrow mesh size, in which you can store a double matrix of U and V mesh sizing seed for when you get to CFD, if you have a particular patch you're concerned about, for example. Advanced links also have their own attributes, and these will be found at the bottom of the advanced link window. And same thing can be done with measures, in which you might say, oh, I want to have the maximum allowable span for, say, a deck limitation. And last of the examples, we have parm references. Or no, not parm reference. This is an attribute on a parm. Important to keep that differentiated. So you might click on the parm for the mass over area of a geom here. So this mass over area might have a certain value, and you want to reference where you got the information from. In this case, we have the lightning protection structure that has to go on a composite layup, as well as a web link to where we got the data from. That's it for the attributable. That's it for the attributes examples. There are many more possibilities that exist. There's no time for a fully exhaustive set. So let's be smart and go to the demo for a minute. I'm going to stop sharing for 1 second while I get my VSP up, if that's okay. Cool. Okay, we are back. And we might notice a couple things here. First, the vehicle note screen, since this was set to true, it was opened when the vehicle was opened. We also have the watermark visible here. I'm going to move this to the left just so it's a little easier to see when we have other windows open. Okay, so let's cover some of the basics here. Let's say we want to have our new geometry here, and this is our blank, and we want to add an attribute to it. So you can't add them from here, but if you double click, that will open up the Attribute Explorer, and it contextually selects the same attribute collection that I double clicked on in some new geometry. Why don't we make a Boolean attribute? And this Boolean is plane flies in sky. Description, an example of a Boolean matter. Value true, thank goodness. Or we actually don't want that to be in attributes. We want it to be in a group that says general concepts matter group. And we want to put that in there. So we're going to cut that and paste. And you can use, of course, the hotkeys as well as the cut and paste buttons. The shortcuts are OS sensitive, so if you're using Apple, you'll see the proper command key, I believe. Rob, you can correct me if I'm wrong there, but I think it does that. Or we don't like where this is, so we're going to just get it out of some new geometry and put it in vehicles. And if you select the object or its base level attribute collection, it will paste to the same attribute collection. And there we go. General concepts adder group. So let's look at some of the vehicle level attributes. We have a map props group we made with some surrogate version of a basic Torre plane weave. We have aluminum. We can close those up here. You notice we have vehicle notes open here, and the string data for the vehicle notes is open here too. And when you see these grayed out screens here for the name and description, you'll know it's a protected core attribute that is interacted with in other ways in OpenVSP. And anything you want. Oh, right. This. If you want to put new lines in the string, you have to do Shift Enter. If you hit Enter, that is the data entry button. So just to know that. The other set of protected attributes are in the watermark group. So we have the toggle for showing and hiding the watermark. We can change the, say, fill alpha to half thickness, half fill, 20% full. The default fill color is a nice green per the Navy's request. I can make it a less nice green, but I like that. Make it big, make it small, make it normal. Okay, what's something else that is interesting? Another thing that's very interesting is if you go to a double matrix, add rows and delete rows, and what you notice here is that these rows are custom names. And that is one of those little tricks we've added in which if you create a comma delimited string attribute with the associated name of the double or integer matrix attribute, you can then create custom rows or column names, and it will go up to the end of that, and then it'll start doing blanks. Now, importantly, you can cut and paste from here, and it will fill in automatically to the new bounds of the matrix. And these can be cut and paste to and from your standard Excel type spreadsheet software. So not too much to worry about there. I would recommend against clicking add row and add call for tens of times, but it's good for filling in small amounts. Let's see, I'm trying to think if I forgot anything here. Let's say we want to copy an attribute to multiple places. Copy, paste. I'm going to hit Control-C for that, and then I'm going to select multiple places and paste it in multiple places. So now we have one here, here, and here. Again, a lot of work was done to make sure this is as intuitive and powerful as possible. Note also the close and open inactive nodes. So if I have these two selected, geom and some new geometry, and I close inactive nodes, then we just have some new geometry and wing geom open. So again, powerful way to open and close context sensitively for getting to what you want to look at. Or you can just open up everything. One thing that I think is at least a particularly fun flourish to look at is the parm reference attributes. So let's say we go to the wing geom. I'm going to add a parm type attribute. And since this uses the same parm picker code as the rest of OpenVSP, we could say drag the length of pod geom in here as an attribute, parm adder. And why you might want to do this is you might want to both get metadata and standard data out of your OpenVSP model through API to one of your aircraft design programs. Because you might just want length of this pod geom in addition to everything else. Because you might be storing metadata like baggage volume and minimum gauge, and you might just want to know how long this thing is too. Now the neat part is now we have control here, and it works the exact same as the original parm control up in the geom window. Anyways, I've probably rambled enough. I should leave some space open for questions. I was having a lot of fun over here. Let's see here. Acknowledgements. Thank you very much, Navy, for funding this under the Phase 2 SBIR from NavAir. It's been a very nice time working on this, and thank you all very much. Anyways.
Thanks a lot, Tim.
Yeah. You're welcome.
The stream lags about 15 seconds, so we'll give people a little bit of time to type any questions that they have into the stream. Andy Hahn did have a question about why you used purple or magenta in particular in the global attribute browser, and you had a slide on that came up afterwards. But you could go back and make sure that that we understand why does things show up in that tree in purple?
Why do things show up in that tree in purple? I can see where that might be redundant. The reason here is you can quickly tell whether something is an attributable object if it's bold and magenta, whether it's merely an attribute, or if it is a attribute group. So attribute groups will be magenta. Standard attributes will be non-bold and black, and attributable objects will be bold and magenta. Because there's no limits on what you can name things. You could call this attributes. And without, let's say this is over here, if we didn't have that bolding and magenta coloration, it might be much harder to tell what's what.
Okay, I think that should answer it. Yeah, OpenVSP in a lot of places doesn't control names. And so if you're sadistic, you could name everything Bob. The wing could be named Bob, the attributes could be named Bob, the parameters could be named Bob. It could be that all the way down, and it would just be completely meaningless.
Yeah, you can change multiple data names at once in the attributes editor too, if you want to be sadistic, as was said.
So
I recommend against this, but you can do it.
It wouldn't be a VSP workshop if we don't show people lots of things that you can do but probably shouldn't.
Any other questions, of course, happy to help.
Sounds good. Well, thanks, Tim. Appreciate the talk this morning. The attributes are incredibly useful, and as has been mentioned in the chat and kind of discussed here, that where this can go is still kind of to be determined. I think it's adaptable in so many different ways, and it's going to be really cool to see what people do with this.
Absolutely.
But
it's been designed with no guardrails, so go wild, have fun. Thank you for your time. Pleased to present.
Yeah, thanks, Tim. Really appreciate it. Thanks for kicking us off today.
Absolutely. Hope to catch you all later on the stream. Bye for now. Thank you.